Good morning, gentlemen. I hope you all had a good first week of school and have settled in well. Okay, in today's lesson, we will be covering area of triangle. So I'm on page 5 of your notes number 11, which is chapter 6, further trigonometry. Alright, so first things first, right over here, we're going to learn all about area of triangle. Now, before we start this part, let me just recap that for any triangle, there are 3 vertices, which will be denoted by capital A, capital B, capital C, for example, or capital P, Q, capital R, basically capital letters to denote the vertices. Okay, and how we would label the sides is like this. So opposite of vertex A, we will have side A, and this is denoted by a small letter. So there's small a to denote this side, which is BC. Okay, opposite of vertex B, you will have side B, and opposite of vertex C, we have side C. Okay, so recall that this is how we label all the vertices as well as the sides of any triangle. Alright, now let us look at these 2 triangles over here. On the left hand side, triangle ABC over here is an acute angle triangle, and on the right hand side we have an obtuse angle triangle. Okay, so let us say we are looking at the triangle on the left. Okay, we have vertex A, B, C, and opposite vertex A we have side A over here, opposite vertex B we have side B over here, and opposite vertex C we have side C over here, like what I just mentioned. So if I were to say find the area of this triangle, what is the formula for area of triangle? It is just half times base times height. Okay, so it is half times B, which is the base, times the perpendicular height, which is H. So this would give us the area of the triangle. Now, how would I express side H in terms of a trigonometric ratio? So, recap that in the previous chapter you learned all about Tuakaso, right? So, let's say I want to express H in terms of that. I'm looking at angle C over here. Okay. So, if I look at this angle over here, sine of angle C is basically equals to opposite over hypotenuse. Okay, so opposite over hypotenuse is just H over A. Sine C is equals to H over A. If I want to make H the subject of the formula, I just multiply both sides by A, and I will get H equals to A sine C. Okay, sine C equals to H over A, right? So H is equals to A sine C. So basically, if I substitute the H over here in half times base times height as A sine C, I will get half times base times A sine C, which brings me to the formula half AB sine C. Okay, so the area of triangle in terms of a trigonometric ratio, right, it will be half times side A times side B times sine of the angle in the middle of the 2 sides, half AB sine C. Okay, the C here refers to angle C because it's capital letter, right? So this is referring to angle C, and A and B are referring to the 2 sides over here. Okay, so A and B are the 2 sides, and angle C is actually in the middle of the 2 sides. Okay, as you can see from the diagram. Now let us see if this also applies to an obtuse angle triangle. So let us look at this triangle over here. It has vertices A, B, and C, and opposite vertex A we have side A, opposite vertex B we have side B, and opposite vertex C we have side C. But just that angle C is now obtuse. That means it's more than 90 degrees. Okay, so let's look at this angle over here, sine C. If I'm looking at this angle, the acute angle sine C, right? Sine C will be equals to H over A, because I'm looking at this dotted triangle over here, right? This is a right angle triangle. Opposite of angle C is side H, okay, and the hypotenuse of this small triangle is A. So sine C is equals to H over A. Now H is also the perpendicular height of this triangle. In primary school, you used to just extend the base and draw a perpendicular height down, right? Okay, so this H is actually the perpendicular height of this triangle ABC. So we already established that sine C is equals to H over A. Now in 6.1, you also learned that the sine of this acute angle will be the same as the sine of this obtuse angle, because sine ACB is equals to sine 180 minus angle ACB. Okay, ACB is this obtuse angle here, right? And BCD is actually the acute angle, the corresponding acute angle. And the sine of this red angle here is the same as the sine of this blue angle over here. Okay, so sine ACB is actually the same as sine BCD. That's what you learned in section 6.1. For example, if you press calculator, sine 30 will give you the same answer as sine 150. Okay, both will give you half. Okay, so basically we can say that sine of angle ACB is still H over A. Okay, because sine of the red angle we found was H over A, right? So sine of the blue angle will also be H over A. So if I were to find the area of this triangle, recall that the area of this triangle is half times base times perpendicular height, right? So my H is now equals to A times sine ACB, or A times sine C, which is the same thing. Okay, because sine C and sine ACB and sine BCD all are referring to the same thing. So H is equals to A sine C. So if I were to substitute this, whatever I've derived, into the formula half times base times height, I will get half times base times H, which is A sine C. Okay, and that brings me to this formula, half AB sine C. So once again, you get the same formula that you derived for the acute angle triangle as well. These two are basically the same. But just recall, or just observe that A and B are referring to the sides. So A is here, B is here, and the capital C for sine C, right? That's referring to the angle between the two sides A and B. So half AB sine C will give you the area of triangle. So in conclusion, all these are basically the derivation of the formula. But basically the main thing you must know is area of any triangle. This applies to any triangle, will be half AB sine C. A and B are the sides, and angle C is the angle in between the two sides. You can pause the video now to sort of absorb whatever was just explained about the formula. But if you get it, we can go on to example 6 to see how to apply this formula. Okay, so example 6 over here. In triangle PQR, PQ equals to 8.2 cm, which is this side over here. PR equals to 4 cm, which is this side over here. And angle QPR equals to 88 degrees. Alright, so you can see that they have given you two sides and the angle in between, which is perfect because we can immediately apply the area of triangle formula to find the area of this triangle. So area of triangle will be half AB sine C, right? Now, if you write just half AB sine C, but you don't know what is ABC, because the question has used PQR, don't worry too much. You should know that the A and B refer to the two sides over here, 8.2 and 4, and the sine of the angle is the sine of the angle in between the two sides. Okay, so it is sine 88. Okay, you don't even write this formula and go straight to half times 8.2 times 4 times sine 88 degrees. And all you have to do is to press calculator. 8.2 times 4 times sine 88. Okay, please confirm that your calculator is in degree mode. Okay, and your final answer should be 16.3900, but we will give it to 3SF. So 16.4 cm square, don't forget your units, and write in brackets 3SF. Okay, very good.